Here it is given that at the moment t is equal to 0, a particle starts moving along x-axis, so that velocity projection varies according to the equation, which is given that Vx is equal to nothing but 35 cos pi t, and its unit is centimeter per second. Where t is expressed in seconds, find the distance that this particle covers during t is equal to 2.8 seconds after the start. So our aim is to find out what about the value of distance traveled by the particle in a time of 2.8 seconds. So from this equation, that is Vx is equal to 35 cos pi t, we can write the equation for its omega is equal to nothing but pi, and we know that this omega is 2 pi divided by its time period t. So we can say that the value of its time period t is equal to nothing but 2 seconds. So in a time of 2.8 seconds, it will complete more than one oscillation. So we can find out exactly what about the value of distance traveled by the particle is. So if the particle is let's say starting from its mean position, then in a time of in time of 2 seconds, the particle will complete one full oscillation. That means particle will move from its extreme position, mean position to extreme position in a time of 0.5 seconds, then again to its another extreme position, then again coming back to its mean position. So which will complete in 2 seconds. Next 0.5 second, the particle will move from mean position to its extreme position. Now the particle is at extreme position when time is 2.5 seconds. Now in a time that is 0.3 seconds, the particle will travel some distance. Let's say it is represented by x dash. So the total distance traveled by the particle will be equal to, we can say that it is 5 times of its amplitude of oscillation plus a distance that is equal to x dash. So we can find out first what about the value of amplitude of oscillation. So according to the equation, Vx is equal to 35 cos pi t, we can say that this maximum possible value of velocity, which is equal to 35. So we can find out, we can say that which is equal to nothing but omega into a. So we can write the equation for a, that is a is equal to 35 by omega. The value of omega is nothing but pi, so we can write it as 35 divided by pi. Now we can find out what about the value of x dash. As the equation for Vx is 35 cos pi t, we can say that t is equal to 0. The particle was at its extreme position. So we can write, if the particle is start oscillation from its extreme position, we can write the equation for displacement, x is equal to a cos omega t. So we can find out what about the value of this displacement. A is 35 divided by pi into cos of omega is nothing but pi into t, which is nothing but 0.3 seconds. So you can write the equation for x, that will be equal to 35 pi into cos of 180 into 0.3, that will be around 54 degree. So we know that in case of if this angle is 37 and this angle is 53, then this side will be 3 and this is 4 and this is 5. So you can write cos 54 here. Cos 53 is approximately equal to 3 divided by 5. So you can write the equation for x, that is equal to 35 divided by pi into cos 54, that we can approximate it as 3 by 5. So again its value will be equal to 21 divided by pi. So over here we can find out what about the value of x dash, and just remember one thing is that this x is displacement from mean position, and our aim is to find out what about the value of this x dash. So this x dash can be written as nothing but this x dash can be written as x a minus x. So we can write the value of x dash will be equal to amplitude of oscillation minus displacement from mean position. So amplitude of oscillation is nothing but 35 divided by pi minus the value of x, which is nothing but 21 by pi. So you can write the equation for it, that is 14 divided by pi will be the value of its x dash. So you can find out what about the net displacement. That is 5 times of amplitude of oscillation, which is 35 divided by pi plus 14 divided by pi. So that value will be around you can write it as it is 5 times of 35, which is 175 plus 14, that is 189 divided by pi, which is equal to 189 by 3.14, which is around you'll get a 60.19, or you can take it as nothing but 60, that much centimeter. Or if we are expressing the answer in meters, then it is 0.6 meters. That will be the answer.